Good morning, everyone. Today we will be studying and demonstrating texture analysis. Texture analysis is the mechanical testing of various kind of products such as food, cosmetics, pharmaceuticals, etc. It is a very important instrument for measure the physical properties of these products. It is an important attribute for processing, handling of the product. Texture also affects the shelf life and consumer acceptance of the products. Texture analysis has become a commonplace in many industries to measure a specific or range of characteristics or properties of the products, such as the way material behaves, breaks, flows, sticks, or bends, etc. The instrument that is used for texture analysis is the texture analyzer. These are the basic parts of texture analyzer. First is the drive system. It imparts motion to the crosshead that holds part of the test cell. It moves the drive system either upwards or downwards. Test cell holds the product sample and applies force to it. And there is a force measuring and recording system which plots the complete history of the changes in force during the test. Then there is the software which is used to drive texture analyzer. It is important for as the basic, it gives the basic instruction and it is very simple to use and offer wide range of tests. For different samples and for different applications, different kinds of probes are used. Each probe or fixture is designed for a specific group of application and can be attached to the base and arm of the texture analyzer. There are multiple tests that can be performed using the texture analyzer. These are the few tests that can be performed, such as uh, texture stress relaxation test, toughness test, hardness. We can also measure hardness, firmness, softness of the product, etc. The first test that will be performing today is the stress relaxation. Stress relaxation is defined as the time-dependent decrease of stress under a constant strain. Stress relaxation is a common phenomenon in polymer composite materials, and the rate of relaxation can be affected by time, temperature, initial strain, environment, and so on. Stress relaxation shows how viscoelastic materials, especially polymeric materials, relieve stress under constant strain. Any product can be of elastic nature, viscous nature, or viscoelastic nature. If the elastic deformation is occurring in a product, then it is elastic in nature. This kind of deformation is recoverable, for example, stretching of a rubber band. In viscous materials, viscous deformation takes place, which is non-recoverable, for example, the flow of honey. In viscoelastic materials, viscoelastic deformation takes place. Viscoelastic materials have both viscous and elastic properties. These materials have a tendency to exhibit stress-strain characteristics. In the diagram given below, you can see different stages of the deformation of the polymer. Polymers show viscoelastic properties. The reason for the polymers to act as viscoelastic material is the presence of large number of molecular chains in it that are usually entangled. These arrangements leads to a large number of chemical and physical interactions in them. If an external force is applied on the polymer, which is already in its equilibrium stage, which is shown here as E naught, due to the presence of various established forces, initially the polymer will display stretching and elastic behavior in order to maintain its desired equilibrium or simply in a state from which it can revert backward to its original form. That stage shown here is as E. If further force is applied on it, then then it leads to the viscous deformation, which is not recoverable. So we can see that if a little force is applied on it, then the material is acting as elastic material, because still it can be recovered to its initial form. But when it further force is applied on it, then viscous deformation is taking place. Hence, it can be seen that polymers are showing both elastic and viscous properties. This is the basic graph of the stress relaxation. If you look at this graph, there occurs a steep increase in the force value from 0 till a maximum stress S naught. At this point, S naught, the compression is stopped and the material is held. After that, the force initially declines very rapidly, after which slowly as the deformation occurs. This decay in the stress relaxation is known as stress relaxation under a constant strain. Another test that I will be performing today is spreadability. It is the ease with which a product can be spread. It is commonly a desired characteristic of food products such as butter, spreads, peanut butter, margarines, cheese, and cream cheese, etc. It is related to the firmness, viscosity, and consistency of the product. This is the basic curve produced from petroleum jelly at different temperatures, that is 5 degrees Celsius and 25 degrees Celsius. Here the positive peaks shows the firmness and negative peaks shows the stickiness. There are multiple applications of the texture analysis. It is used in research and development, in longer term studies to understand micro and macro structures, or in the development of new ingredients or unique products. It is also used in new product developments to monitor the effect of formulation and shelf life. It is also used in process development to maximize product quality. These are the different sectors in which texture analysis is used very frequently. It is used for the quality and quality checking of various products such as dairy products, fruits, vegetables, personal care products, pharmaceutical and medical products, etc. Thank you.